Hello everyone, my name is Madhuri Metkar. I am a third year aeronautical student from Anna Sahib Dange College of Engineering and Technology, Ashta. Today I am giving a presentation on the topic of basic concepts of space dynamics. This is our ISC 1 activity 1 of subject space dynamics under guidance of Mr. Sabrishwar. So these are some contents which we will see. The first one is solar system, then the reference frames and coordinate system, then celestial sphere, then ecliptic plane, then the motion of vernal equinox, then sidereal time and solar time, and the Earth's atmosphere. First, we will start from the solar system. We know the solar system contains 8 planets like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune in specific order, in which the Sun is the center of the solar system, which held all the planets together by using immense gravitational pull of attraction. You can see here the living picture of our solar system, where all planets are rotating around the sun in specific manner in a specific orbit with with their orbits. Then we will introduce the space rocks. First one is asteroid. These are the big chunks of rocks of metal that are mostly found orbiting the sun between the Mars and Jupiter. You can see here the midway between the sun and Mars and Jupiter. The asteroids are present in a large amount, which are also moving in orbit. They are large in amount, but they are not visible from Earth with the naked eye. The current known asteroids are 12,67,143. Then we will introduce another space rock named as comets. Comets are the cosmic snowballs of frozen gases, rock, and dust of orbit of the sun. The comets having a different shape than the meteoroids or asteroids, which it having a dust tail. You can see here the schematic diagram of the comet, and the visual diagram also is given to visualize more the comets. The comets are large in number. They are millions in our solar system. Then we will further move towards the meteoroids. Meteoroids are the objects in the space that range in size from the dust grain to small asteroid, thick of as space rocks. When meteoroids enters Earth's surface at high speed, it burns up, and the fireball. It looks like a fireball, so we can call it as a shooting star. So you can see here the picture of the shooting star, which is nothing but the meteoroids. Same, these are the space rocks which we seen before slides, like asteroids are there, meteoroids, comets, etc. Here from onwards we will learn about some different spheres like this celestial sphere and different reference frames. You can see here the schematic diagram of celestial sphere. You can see at the equator of the Earth, the celestial equator is shown with the bluish area. This is nothing but the celestial sphere, which gives the position of the star or planets on the sky in an absolute sense. It protects the Earth's spherical surface onto the sky, called the celestial sphere. By using this celestial sphere concept, we can find out the exact position of the planets or stars in the space. Then the ecliptic. The ecliptic is the name given to the path of the sun follows through the stars and constellations over the course of the year. You can see here the motion of Earth around the sun, which takes place 1 year to complete one revolution around the sun in ecliptic manner. Then we will learn about the obliquity. It is the tiltation of, we can say, the tiltation of the Earth by the effect of it gives a sunlight. It gives the path to sunlight to enter on our planet. Because of the rotational axis, the Earth is tilted from the vertical, but the angle which is made by the Earth by tiltation, it is known as obliquity. You can see the visual image here, which will clarify the obliquity. Now we will learn about the equinox. Equinox is a moment of the time when the Earth's axis tilted neither toward or nor away from the sun, making day and night. So here also you can see the image of the Earth's rotation. Because of it gives the effect of day and night. This the motion which is which gives the result of day and night. It's nothing but equinox. So because of the rotation from south to west, the 12 hour of daylight and 12 hour of night we get daily. And the speciality is on the March 20, the vertical equinox will signal the coming of the spring for the northern hemisphere. Then on the September 23, the nature will once again bring the autumnal equinox, the time of the year that uses in the all of the in the north. Then the geocentric reference frame. It is a three-dimensional where the earth is a center, and here the x, y and z axes are used to identify the location of the reference system. Here the x-axis is equatorial plane, y-axis also is equatorial plane, and the z-axis coincides with the polar axis and is a positive towards the north pole, and the origin located at the center of the sphere or spheroid. Then geocentric rotating reference frame. Here the geo means the conventional international origin, and here also the earth is the center of mass. Here the z-axis is earth rotational axis, x-axis is equatorial plane crossing the upper branch, y-axis is equatorial plane also. And here we can visualize this geocentric rotating reference frame by using the right hand rule. Then now geocentric non-rotating reference frame. Here the center is earth, likewise a rotating reference frame, and the z-axis is earth's rotating axis, x-axis is equatorial plane, y-axis is also equatorial plane, and here also we can visualize this geocentric non-rotating reference frame by using a right hand rule. Then now we will move towards geocentric non-rotating elliptical reference frame. Here we can see the diagram or the picture of the geocentric non-rotating elliptical reference frame, where the center is earth, x-axis is elliptical plane, y-axis is elliptical plane, and z-axis is elliptical north pole. And here also we can visualize this geocentric non-rotating elliptical reference frame by using right hand rule. And now the motion of the vernal equinox. The vernal equinox occurs when the tilt of the Earth rotation axis reaches a particular position. We are aware that the imaginary axis, the Earth spins around once every 24 hours. Here we are trying to say that uh, we know the Earth Earth wants 24 hours to revolve itself with a complete. Then here you can see the image which is showing the rotation of the Earth and the axis which is tilted in 23.5 degree. And now we will see the solar time and sidereal time. The solar time is a calculation of the passage of the time based on the position of the sun in the sky, and the fundamental unit of the solar time is obviously day. And for a sidereal time, the time is a scale that is based on the Earth's rate of rotation measured in relative to the fixed stars. So you can see here the motion of the planet or Earth around the sun, which differentiate the sidereal day and solar day by considering time as a most important parameter. Here you can see for solar day it needs 24 hours, but for sidereal day it needs 23 hours 56 minutes and 4 seconds. This time difference makes the difference in between both days. The same thing which I told in the last slide is presented here, the sidereal day and solar day, and the motion of both, uh, the motion required for both days, or we can say the time required for both days. So the last part of our presentation is Earth's atmosphere. We are seeing here the layers of atmosphere which are differentiating by using the distance of that layer with respect to Earth. We can see here the troposphere, stratosphere, mesosphere and thermosphere, and in between the stratosphere and troposphere the ozone layer is there present, which is very useful to us. Because of that we are not getting harmful rays on the Earth. So here my presentation completes. So thank you very much.